In this video, we're going to be going over some practice problems for writing names and formulas. And this is our part 6 video inside of chemistry, chapter 2. So starting off with practice question number 7. So we need to write the formula for each of the following compounds. So on the left here, we have a few different compounds that we have, and all we need to do is just write the formula for them. So I'm only going to explain maybe the first one or the first two, and after that you can try them all out for yourself, and I'll show the answer so you can see if you're right or wrong. So for the first one, we have beryllium fluoride. And in order to write the formula, all we need to do is just know the outer shell of both of these atoms. So in order to do this, let's start off with beryllium fluoride. So on the right here, I have both of the configurations of both of them. So beryllium is on the top and fluorine is on the bottom. So in order to combine both of these, we need to see what electrons and what valence electrons go to each one. So since beryllium is on the left side of the periodic table, that means it's the metal. And on the right side, we have fluorine, which means it's a non-metal. So this is an ionic compound. And the formula that's going to come out, we need to look at the outer shell. So beryllium has 2 in the outer shell. So we can see here in the first picture, beryllium has 2 different atoms on the outer shell. And then on the other hand, fluorine, if we look here, then fluorine has 7 in the outer shell. So we can see that automatically these two don't combine exactly perfectly together, because since beryllium has 2 to give and fluorine has to receive 1, it's not going to match. So we need to add another fluorine atom. So if we have 2 fluorine atoms, then fluorines can receive 1 each from beryllium. So that means that beryllium is going to give 1 to one fluorine atom and another one to another fluorine atom. So the formula for this should be Be, which is beryllium, and then fluorine. So 2 of them. So F2. So it should be BeF2. So if we look at the answer, we have beryllium fluoride is BeF2. And the same thing for the other ones, we can do the exact same thing. All we need to do is look for the outer shell. So if we start with the next one, which is sodium nitrate, if we pull out our periodic table, so if we look for sodium, it's 11. So that means it has 1 extra in the outer shell. So that means it's ready to give 1 more. And if we look at nitrogen, which is N, where nitrogen is right here. So since nitrogen has an atomic number of 7, that means nitrogen has 5 in the outer shell, and it's looking for 3 more. So since sodium has 1 in the outer and is ready to give, and there's nitrogen has 3 to receive, all we need to do is make 3 different sodiums, so 3 sodium atoms, and then once we have 3 of those, then it can combine with nitrogen, so it'll become Na3N. So since we covered the first 2, and you have a pretty good understanding of how to do it, you can look through the rest and try solving them by yourself, and feel free to also comment the answers that you got and see if you got them right or wrong. So let's now move on to practice question number 8. So in this practice problem, we need to find the charge on the cation on all of these compounds. So in order to find the charge of these cations, it's really simple. All we need to do is just look at the outer shell of the last element inside of the formula. So in this case, for example, let's look at the first one. We have copper 2 and then S. So we're looking for the charge of the cation, and cations are always in the front of the compound. So that means in this case, copper would be the cation, and the next one would be chromium and then lead. So all of the ones in the first is going to be the cation, and the ones in the back is going to be the anions. So in this case, if we need to find the charge, let's look at the back element, which is the anion. So in this case, sulfur is in the back of the first one. So the sulfur's atomic number, if we pull out the periodic table again, so sulfur has 16. So that means that sulfur has 6 in the outer shell. So since it has 6, it's looking for 2 more. So that means if it's going to look for 2 more, then it means it's going to gain 2 electrons. And if it gains 2 electrons, then sulfur will have a charge of -2. And since it has a charge of -2, we need copper to satisfy that with giving +2. So since we have 2 different copper atoms, we can see that it's Cu2. So if we have 2 different copper atoms, that means each single one of them is going to have a charge of +1. So that means the cation, copper, in this case will have +1. And since we have 2 of them, it's going to make +2. So let's look at the answer. So for the answer, copper in Cu2S has a charge of +1 because sulfur typically has a charge of -2. And since there are 2 atoms of the copper to balance out the single sulfur ion. So that's how you actually do these questions, and we're going to cover over one more. So for this one, we have Cr2O3. So Cr is chromium and O is oxygen. So in this case, let's look at the outer shell of oxygen. So since it has an atomic number of 8, that means in the outer shell, oxygen has 6 electrons. So since it has 6 electrons, that means it's going to receive 2 more electrons. So that means every single one of them is looking for 2 more. So since we have 3 of them, we're looking for 6. So that means all these oxygens have a charge of -6. So that means in chromium, so since we have 2 chromiums, we need to make up -6 and balance it out with +6. That means one chromium atom will have +3, and if we have 2 of them, then it's going to make +6, and then it'll balance it out. If we look at the answer here, chromium in Cr2O3 has a charge of +3 because oxygen has a charge of -2. And then we're going to get -6 for oxygen and then +6 in chromium. So this is practice question number 8. Feel free to do all the rest of the problems, and we're now going to move on to practice question number 9. So for practice question number 9, we need to copy and complete the following table by adding the missing stock system names. So we talked more about the stock system in our chapter 2, so you can find the video out there on our channel and watch that if you don't know how to do this. So in order to do this, all we need to do is, it's really simple. So we know that the cations are always going to be in the first. So if we look at the first example here, we can see that iron is going to be in the first because it's the cation. So based on what it is, so in this case it's 3+, that's why we have iron 3, and then we have chlorine. So if you combine iron 3 and chlorine, then it makes iron 3, then chloride. So this would be the name. So if we look at the next one, we have FeO. So in this case, Fe2+, so that's our ion, we have a 2+ ion for iron. So in this case, we're going to have iron 2, and that symbolizes the ion of Fe2+. And once we combine this ion of Fe2+ with oxygen, then we're going to get outside of oxide. So we're going to have iron 2 oxide. So let's look at the answer. So as we can see here, we have the formula as FeO, the ion Fe2+, and then for the name we have iron 2 oxide. And similarly, you can do the same thing for the next two, and we're going to move on to practice question number 10 now. So for practice question number 10, write the chemical formula for each of the following compounds. So here we have a list of different compounds, and we just need to write the chemical formula. So all we need to do is basically from the name, just write the formula. So in this case, we have copper 1 and then oxygen, so oxide. So what we need to do is check out the outer shell again of oxygen to see how many electrons it needs, and based on how many electrons it needs, we know that how much copper has to offer. So if we look back at the element of oxygen, it has an atomic number of 8, which means it has 6 in the outer shell, and that means it needs 2 more in the outer shell to have the complete valence electron. So since it's looking for 2 more, that means copper has to supply 2, but since copper has a charge of +1, that means it's only giving 1 electron. So since copper is willing to give 1 electron, then that means we need 2 of them, so 2 coppers, and then it'll satisfy the equation. Since oxygen needs 2, and then if we have 2 coppers, then they're both going to provide 1 electron, and then it'll satisfy the equation. So in this case, it should be Cu2O. So as we can see in the answer, we have Cu2 and O. And similarly, you can try out the rest of the problems. So for practice question number 11, the question is, explain why you must use the SOC system to name ionic compounds containing transition metals, and in which cases do you not need to use the stock system to name an ionic compound, and explain your answer. So for this question, we already know, if we watch the previous videos, the reason why we need to use a stock system for most of the transition metals, and that is because these transition metals have more than one different cation. So since if you have more than one cation, we use the stock system to show the differences between the cations. So for example, in copper, we use copper 1, in the brackets we use the Roman numeral number 1, or we might use copper 2, or iron 2, iron 3. So we use the stock system in order to specify the different cations. And we won't use a stock system in normal ions, such as sodium. So sodium only has one type of cation. So since it only has one type of cation, we're not going to need to use a stock system because we don't need to specify which type of cation is, since it only has one. So let's look at the answer and see what it says. So for the answer, the stock system is used for naming ionic compounds containing transition metals because these metals can exhibit multiple oxidation states. So as we said, inside of copper, there's a copper 1, that's one oxidation state, and there's another one, which is copper 2. And you do not need to use the stock system to name an ionic compound when the metal has only one possible oxidation state. So that summarizes everything for this question, which is practice question number 11. And now we're going to move on to our final practice question, which is number 12. And the question is, there is something wrong with the name written beside each of the following compounds, and in each case explain why the name is wrong and then write the correct name. So the question here is on the left. So basically what we're saying is the formula is right. For all these, the formula is right. It's just the name that is wrong. So we need to fix the name. So for the first one, we have Ti2O3. And Ti is titanium and O is oxygen. So in this case, it's saying the name is dititanium trioxide. So it's obviously, this sounds wrong because it's not going to be dititanium since titanium has multiple different oxidation states. So since it has multiple different oxidation states, we actually have to look at the outside layer, the outside shell of oxygen, and from there we can find out how many titaniums we need and the charge of it. So if we look at the answer here, so Ti2O3, which said it was titanium trioxide, the name titanium trioxide is actually not in line with the chemical name convention. So titanium can have multiple oxidation states, so the correct name is titanium 3 oxide. And this indicates that titanium has a +3 charge inside of this compound. So in this case, that would be how you say it. And similarly, you can try out for the next ones. For example, for the next one we have B, and in this case is NaCl, and here we're saying that it's sodium 1 chloride. So the reason why this is wrong is because sodium only has one oxidation state, which means it only has one cation. So since it has only one cation, that doesn't mean we need to use, so that means we don't need to use the stock system. We only use the stock system if it has more than one. So since sodium has only one common oxidation state, which is the +1, it's not necessary to use the stock system. So the correct name is just sodium chloride. And similarly, you can try out for C and D. And that summarizes all the practice questions for this video. So thank you so much for watching from Try to Be Useful, and we'll see you guys in our next video.